Again, this one, extraordinarily generous. There's no coefficient of t squared, which if there was, then we would have to divide all the terms by that. And yeah, you can end up with fractions sometimes. But right here, what I would like is to isolate the t squared and t, all my t terms. So I would like this to just end up being t squared minus 6t. And I do not want, not 60, but 6t. Sorry about that. The negative 47, I got to zero that out. So add 47 to both sides. Okay, so it's going to equal 63. Yeah, that was good. Now, why did we do that? It's because I'm looking to complete the square of these two terms. Again, that's a perfect, it's going to be a perfect square trinomial. So it's t squared minus 6t, and I got to have a value right there. Now, since it's an equation, again, since it's an equation, it is a principle of equality. If you do something to one side, you must do it to the other side. So I'm going to take my middle coefficient there, which is negative 6. I'm going to divide that by 2, and I'm going to square it. Okay, so just by working with the order of operations, negative 6 divided by 2 would be negative 3. I think I did that right this time. And then negative 3 to the power of 2, negative 3 times negative 3 would be positive 9. Okay, now that 9, I'm going to add it to the t squared minus 6t because that completes the square. It makes these three terms a perfect square trinomial, but it's an equation, so if I do it to one side, I need to make sure to do it to the other side. Okay, now I know that 63 plus 9 is 72. That's not bad. But my perfect square trinomial over here, the 9, right? What two values of 9, factors of 9 add up to negative 6? It'd be negative 3 and negative 3. It's the same value, so I'm just going to write it as a square binomial. So that'd be t, but those are negative 3's there. Okay, so this is my new equation. Now I will square root both sides, but since I'm square rooting a square, I'm going to split this up into two separate equations. So now I've got t minus 3 should equal the square root of 72. I'm not going to make the same mistake last time. I'm going to put this in the calculator so I know if it can be simplified, which it can. So but also t minus 3, if I could get this to equal the negative square root of 72, that'd be good as well. Okay, but this becomes an equation that we just need to solve here at the end. So we'll add 3. I'll simplify it still, but I'm going to wait till the end. So now we've just zeroed out those negative 3. So we'd end up with t equals, I've got 3 plus the square root of 72 there. But also on the other one, I got t equals 3, but now minus the square root of 72. So 72, one of the factors is 36. So the square root of 36 is 6. Should be 6 times the square root of 2. But I'm going to put this in the calculator just to make sure I don't make any mistakes, or hopefully. So I get both answers now. So I got t. I could have it be plus square root of 72 is 6 times the square root of 2, or so I got my comma there. You could have 3 minus 6 times the square root of 2. Now this one, it doesn't have any I values in it. So if you were wanting to try this, you could plug this in or just use the store function of the calculator and then just type in your equation. You will get two true statements. 3 plus 6 times the square root of 2 squared minus 6 times that minus 47 is going to be 16. Same with this other one.